Okay, class, we're about to start section 2.4. Slope is a rate of change. It says here, construction crew is resurfacing part of a highway. They began on May 5th at mile marker 136. On May 21st, they had completed the resurfacing through mile marker 152. Find the average rate at which the project is being completed. So we could write this as an ordered pair. We could say on May 5th, we'll put 5, marker 136. That will be that order pair. May 5th, marker 136. Then on May 21st, we ended up at marker 152. Now, doesn't this look like what we use in order to find the slope? Now, but what we could do is write this out as a rate of change. First, we could ask this question. How long did it take in days for us to get to the mile marker 152? If we look at that, we would take 21 minus 5, and that would give us 16 days. We started on the 5th, ended on the 21st, so we'd take 21 minus 5, which gave us 16 days. Now, we want to figure out how far have they gone as far as in miles. So we would take the 152 mile marker minus the 136 mile marker. 152 minus 136 gives us 16 miles. So now we will write this as a rate. We will have our miles on top, which would be 16 miles. And on the bottom, we will have how many days it took, which is 16 days. Now, this goes back to the independent and dependent variable. We know the days are independent of the miles. So the days are the independent and the miles are the dependent. So 16 divided by 16 is equal to 1 mile per, or divided by 1 day. So it's 1 mile per day. And that is the final answer. That is the rate they're going, 1 mile per day. Now we have example 2. It says the percent of babies born to unmarried women in the U.S. has been increasing approximately linearly from 10.7% in 1970 to 40.8% in 2010. Find the average rate at which the percentage of babies born to unmarried women is increasing with respect to time. Okay, so now we have 1970 and we also have 2010. So what we could do is this here. We will first put 1970, so we could put that as 70 to represent 1970. Well, we could put 1970. So we'll put 1970, and that would give us 10.7%. That will be our first ordered pair. And then 2010 was 40.8%. And just as we did in the other problem, this is what we would do. How long did it take? So we'll take 2010 minus 1970, which gives us 40. So that's 40 years. And then we would say how much has the percent increased. So we would take 40.8% minus 10.7%. And that would give us 30.1%. So that is the level of increase. Now we want to do the rate. The rate would be 30.1% divided by the amount of years, which is 40 years. 30.1% divided by 40 years will give us 0.7525% per year. And that is it for that problem. Now we go down here. It says rate of change. A rate, aka speed, that describes how one quantity changes in relation to another quantity. The rate of change in y divided by change in x. So we have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If either quantity does not change steadily, This formula is the average rate of change. If both quantities change steadily, there is a linear relationship between the two variables. Common rates of change, miles per hour, miles per gallon, and cost per hour. You need to know that. And one other thing you need to know, this word per is typically denoted by the division slash here. So when you see that in these problems, that means per. Now it says, does this formula look familiar? It should. It's the same as the slope formula. That's why it should look familiar to you. Now we have a reminder. Linear models will be of the form y equals mx plus b, but the variables will not always be x and y. Now we go here to example 3. It says retail sales of skincare products were $4.7 billion in 2002 and have increased by an average of 0.23 billion per year. It says here, write a function that models the situation, making sure to define your variables. Okay, so first, we know that our x will be our years. Okay, now our y would be our billions of dollars. Because that's what we're measuring everything in. Now, if we look up here, it says it's 0.23 billion per year that is increased by. So this is your rate, which is equal to your m. So now we could write this model. We have y is equal to mx plus b. Now we need to substitute. We have y is equal to, our m is this rate of change here, which is 0.23. We don't have to write billions of dollars because y is already assumed to be in billions of dollars. So it'd be 0.23x plus, now remember, you started off with 4.7 billion in 2002, so that 4.7 will be your y-intercept. So this right here is your answer. Okay, now, one other thing. For this x, we should have put years since 2002 because we always want to include our starter year and the units. So now we have B. It says, using the model, predict when retail sales of skincare products were $3.5 billion. So what we would do is this. We would have y is equal to 0.23x plus 4.7. Now we're given what y is, which is 3.5 billion, which is 3.5 equals 0.23x plus 4.7. We subtract 4.7 on both sides. And this will give us a negative 1.2 is equal to 0.23x. Now we divide each side by 0.23. And our x will equal to a negative 5.22. So what we need to do is, this is approximately negative 5. So we'll go back to our beginning time, which is 2002, and subtract 5. And that will give us approximately 1997. So our final answer here would be about 1997. Okay, now we come to example 4. It says, people who travel to mountainous areas sometimes get altitude sickness. This is caused by the fact that at higher elevations, the atmospheric pressure is lower. At sea level, altitude of 0, the atmospheric pressure is 29.92 inches of mercury, and it decreases by 1 inch of mercury per 1,000 feet of altitude. It says, write a function that models the situation. Make sure to define your variables. So let's take a look here. We will have x is equal to the altitude in 1,000 feet. And then Y is equal to the pressure in inches per mercury. Now, remember here, whenever we do this, we always must include the units. Always include the units. So we will have Y equals mx plus b. Now we look here, our rate is described here, or our slope. It says it decreases by 1 inch. So since it decreases by 1 inch, so we know our m would be -1. So we have -1x plus. Now, remember, at sea level, which is altitude of 0, the pressure is 29.92 inches. So it'll be plus 29.92 because that is when y is 0. So our answer here will be y equals -1x plus 29.92. Now it says B, Denali in Alaska is the tallest mountain in the U.S. with a height of 20.32 thousand feet at the peak. What will be the atmospheric pressure on a mountaineer on the summit of Denali? So we would take this equation, y equals -1x plus 29.92, and we would substitute in the 20.32 and bring down our plus 29.92. So when we multiply this out, this would give us y is equal to 9.6 inches per mercury. And this is our final answer. Now we're on example 5. It says the average cost for a top ticket at a Broadway musical has increased dramatically. Okay, we have the year and we have the average top ticket cost. And we have also a graph here with the Broadway musical ticket cost. Okay, it says consider the scattergram of the data. Does a linear model appear to be appropriate? And explain. We would say yes, because the points are mostly forming a line. Because if you look at the points, they're basically almost going in a straight line here. Okay. Now it says consider the scattergram of the data. Explain why linear regression would be the best way to find an equation of a linear model for these data. And that is because linear regression uses all of the points. Now we come down to C. It says let C is equal to f of t be the average cost for a top ticket at a Broadway musical in dollars, t years since 1970. Find an equation of f, give 3 decimal places. Now you will need to put all this data into your calculator and it will give you the linear regression model of C is equal to 3.933t minus 11.025. Now, of course, in your calculator, it's going to have y, and this will be x. So you have to put in c for y and t for x. Now it says, what is the slope of c is equal to f of t? Now, if we look here, it would be actually 3.933. And then it also asks, what does it mean in this situation? I don't have that question there, but you do.